So first we look on the abstract. So for our overall report is due about the structural behavior of a square wooden table under a static loadings was studies using by analytic beam theory and finite element analysis. And then is the table was simplified as a beam with four supports that where the tabletop distributions the load to the four cantilever legs. And the next one is we also calculate about the bending stress, deflections, and factors of safety were calculated by using the mechanics of material and verified using the LISA FA software also. So next we do about some briefly introductions. So the tables are widely used in our daily application, but their structural is integrity is often overlooked from an engineering perspective. So at first, the wood is a specific European oak hardwood and is selected due to its high stiffness, strength, and sustainability and making it more suitable to furniture structures. And the second is the analytic beam theory is used to calculate the reactions, stresses, deflections, and the factors of safety under the static loading. And the last, the finite element analysis is also using the LISA software to verify the analytical result and compare both methods for the structural evaluation from the theoretical part and the real life parts.
Moving to hand calculation, this is our free body diagram. So we can see they got a distributed load with the small w acting at the tabletop, which is our beam. And then below beam, we got four support. The support reaction is RA, RB, RC, and RD. And at the 3D isometric diagram, you can see the distributed load can be converted to a force, which is W, acting at the midspan. So next, this is how we get the support reaction, which by using the W equal to 4R, and then we got the 61.3125 N for each support reaction force. And then the shear force diagram, we multiply the reaction force 2 because we consider at 2D plane. Free body diagram, we got RA and RB acting at the both left and right side. The right side is about RC and RDs, and the maximum moment we're using this calculation, 1 per 2 times RAB times L per 2, but by referring the shear force diagram, the half triangle formula. So this is how we got the bending moment diagram. So this is our maximum bending stress, 0.809 megapascal, and then the maximum deflection is about 9.2735 times 10 power 6 meter. For the FOS is 12.85, which is bigger than 1. So the structure is safe and reliable.
So the previous slide is about our design, FEM design in the LISA. And here we come to the model detail. And first picture is about the material we're using. We only define Young modulus and Poisson ratio and without any geometrical because the design is fully drawing by points. And next, we only define with one force because we only have one load at the center, so there is only a y negative y load. And for the leg part, or we can say the displacement part, in every leg, we already define every point in the leg which have zero displacement in x-axis, y-axis, and x-axis, and also have zero rotation in x, y, and z. So in the part two slide, we already show the model design and also model detail. Now we come to a model dimension. So for the our dimension, the actual height of this table is 450 millimeter, but the top 50 millimeter is the thickness of the top surface. So we only measure 400 millimeter as the length, the feet height. And also for the feet, its wide and length is both 50 millimeter. And for the total length of a table is 550 millimeter at length and also wide. So after all the design part, we come to the simulation. So this is two major aspect that we are using in our project. So first one at the left side is a displacement in y, and right side is a stress yy, or we can say bending stress. So in both results, we can see that the main force main load is applied at the center of the table, so making the table is sinking into inside inward. And in dimension y, the leg is bending outward. In fact, in bending stress, the leg didn't bending outward, it remained as its shape, although it's also received some force. So just now is a visual result of our simulation. So now we come to some analytical result for our simulation. So for the reaction force, we can see that there are some zero value in the reaction force because we are using coordinate, which is a square with a center point. So for the center point, it doesn't receive any reaction force because all the force is spread into others into surrounding point. So there are some zero in the center, and after I will calculate every leg have total reaction force is 61.3125 Newton in four leg using same value. So just now is about our reaction force. So now we come to a complete table which include the Chauvet interest and also the maximum displacement. So now we discuss first from all of this value we can find the maximum deflection or maximum displacement, which is 7.2584 times 10 power of the negative 9 meter. And next for the maximum bending stress is 0.04804 megapascal.
In a conclusion, this project is verified the structural integrity of a square European OAK table under a 25 kg load, confirming it is structurally sound with a high factor of safety, which is 12.85. The maximum bending stress is 0.809 MPa, remains significantly below the material yield limit, while deflection is negligible at 9.227 power of negative 6 meter. Furthermore, the close agreement between the analytical solution and FEA simulation validates the reliability of the simplified theoretical approach for evaluating wood-based furniture. Next, for the recommendation, we should consider a dynamic loading. Future analysis should include impact and vibration, example like dropping objects rather than just a static loads. Next is model realistic connection, like simulate actual joints such as screws, glue, instead of perfect rigid boundaries to better identify the weak points. Next is use orthotropic properties, account for wood grains, direction, and moisture content instead of assuming it a uniform material. Last but not least, refine mesh density. Increase the mesh density in the simulation to improve accuracy and reduce deviation from theoretical result. Thank you.